Today we want to talk about this letter of the Greek alphabet. This is the letter sigma, and sigma in math is used to represent the sum of a series, the sum of a bunch of terms all added together. So let's just do an example of how this would work. Let's suppose we have the sum represented by that symbol as k goes from 2 to 5 of 2k plus 1. All right, so this symbol represents a series of numbers. And so how do we get what that series of numbers is? Well, what we do is we take the bottom value of k equals 2, and we substitute it into our formula on the right. So 2 times 2 plus 1. This is my substitution for k equals 2. And if I work that out, this is 5. 5 is the first term in our series. We're then going to take the next number after k equals 2, so 3. We're going to plug 3 into our formula on the right. This is what we get when k is 3. We're going to work that out, and that's 7. And that's our second term in the series. We're then going to take the next number after k equals 3, so k equals 4. We're going to plug that into our formula. This is k equals 4. We're going to work that out. That's 9. And then we're going to take the number after 4, 5, which you'll notice is the number on the top of our sigma symbol. This will be the last number that I substitute into my formula. So plug in 5. This is k equals 5, and we get 11. And so what we're saying is that this symbol, this sigma notation, represents this series of numbers, these numbers added together. Now, we've only got 4 terms here, so to get the sum, I can just simply add them up, add the 4 numbers up, and I get 32. The sum of the series is 32. Now, just a couple of things I want you to notice about this particular series. It's an arithmetic series, which means it's a series in which we're adding a constant amount going from term to term, in this case 2. And we know in our work with arithmetic series, D represents the common difference 2. And we can also see in this series that we have 4 terms. And if we think about why we have 4 terms, it makes sense because we used k equals 2, k equals 3, k equals 4, k equals 5. We used every k value from the bottom k value to the top k value. And we can see that that represents 4 terms. Now, we're going to go into situations where we have more terms in the series in which we're not going to necessarily be able to count the number of terms we have. But it seems to reason that in this case where we have 4 terms, we use 4 different values of k, that we could take the top number of k on the sigma notation, subtract the bottom number of k, and we would say, is that the number of terms? Well, we'll notice that that's only 3, because subtracting the k values is giving us the number of jumps going from term to term. Okay, and so there's 3 jumps, but there's actually 4 terms. So what we have to do to get the number of terms is, yes, subtract the top k minus the bottom k, but then we have to add 1 to compensate for the first term that hasn't been counted. So what I'm saying is, to get the number of terms, we can take the top k value minus the bottom k value, and then add 1, which will ensure that we have counted our initial term. Now, I mention all that detail because what if we want to take a series that has many more terms? Let's suppose we've got a series going from k equals 10 up to k equals 100. And let's actually take the same formula. Now, based on what we just said, the number of terms in this series will be the top value of k minus the bottom value of k plus 1. And that would be 91. So 91 terms in this series. What are the terms themselves? Well, we can generate a few of the terms. We obviously don't want to write out 91. We can generate a few by substituting in a few values of k. So 2 times 10 plus 1, my first term would be 21. This is for k equals 10. Then we do the next value of k, 11. Substitute 11 in, and we get 23. Substitute the next value of k in, 12, and we get 25. And if we keep doing that, we can go to the end. The last term is found by placing k equals 100 into the formula. And if we do that, 2 times 100 plus 1 would be 201. So again, here is our series that this sigma notation represents, the addition of all of these terms together, all 91 terms. Now, if we want to find the sum, it's not convenient to manually add up all 91 terms, so we can take advantage of one of our arithmetic series formulas for sum. And as a reminder, here are those formulas. Sn, the sum of an arithmetic series. We can use either of these two formulas. So what we're going to do is we're going to take our series and we're just going to take stock of which variables we have. Remember, A represents the first term in the series, which would be 21. Our D is our common difference, as we said before. This is an arithmetic series we're adding 2, so D is 2. N is the number of terms or the position of the last term. Well, our last term is term 91. We have 91 terms. That's what our N is. And if we wanted to use L, the last term, which is term 91, that would be 201. So we're in good position to use either of the two formulas to calculate the sum. And so let's make our life easy by using the shorter of the two formulas. The sum of n terms is the number of terms divided by 2 times the first term plus the last term. And we're going to substitute. We're doing the sum of 91 terms. You'll notice that I'm using these values for the formula. I'm not using the k values. The k values were simply used to generate the series itself. Once we've generated the series, we've converted that information over to these variables that match the variables in our formula. So we have 91 over 2 multiplied by 21 plus 201. So 91 divided by 2 is 45.5. 21 plus 201 is 222. And if we multiply those two values together, we get 10,101, which means that all of our 91 terms above, the sum of that series is this value.